Okay, so today we're going to discuss the MRSM paper 2 paper, and we're going to do this in two parts lah. Okay, so this first part is going to talk about the section A questions, the structured questions, and then the next part, which is tomorrow night, we will talk about the section B and section C questions. Okay, so now that we are beginning this, so this is the paper. I hope that you have the paper with you. I'm not really sure who doesn't. I mean, if you didn't go to school, then I guess you didn't do the paper lah. But what I want you to notice, firstly, kalau kamu bandingkan all the papers that we have, is that the formula list is different for different papers. Okay, in the MRSM paper, they give more formulas lah. Okay, but that doesn't mean that this is the formula list that akan diguna pakai untuk setiap lesson. So in this one, there's 40. Okay, and if you notice that it's kind of like all jumbled all over the place, except that 21 all the way until 34 is chapter 3 form 4, gravitation. And after that, 35 is Planck's constant. So constants are usually given. Okay, constants are usually given, and you're required to know that lah. Mass of Earth, radius of Earth, mass of the Sun, gravitational constant. All these are constants. If they are not given in the question, they will be given in the formula list. So it is important that you pay attention to the formula list lah. Okay, to know that okay, apa formula yang diberi, and especially what are the constants that are given. Okay, so pay attention to that. All right, let's begin with this one. So diagram 1 shows a lady spinning an iron ball tied to a string with force F to maintain its circular motion at uniform speed V. Okay, now this is a similar question to the one that we've discussed previously with the SBP paper. Okay, and we know that the force that is involved in a circular motion, okay, is known as the centripetal force. Okay, this is standard lah. Okay, and if you remember our discussion from SBP last time, the same question again. Draw an arrow to show the direction of the force that acts on the string. The direction of the centripetal force is always towards the center. Okay, and I'm going to label this as F lah. Yeah, okay, F to show the direction of the force. Okay, all right. Next, state one factor that affects the speed V. Okay, so there are actually two factors lah. If you remember centripetal force, okay, let's take a look. So the formula for centripetal force is this: F equals to mv squared over r. Okay, so F equals to mv squared over r is the formula for centripetal force. Okay, and when you look at it, you will see that actually there are two factors, okay, that affect the speed, which is either the mass or the radius. Either one of these answers will be acceptable. Okay, either the mass or the radius will affect the speed of the linear speed actually, okay, of the centripetal force. So of course this is very logical. The bigger the mass, the smaller the speed. Okay, and of course the smaller the radius, the bigger the bigger the radius, the bigger the speed. Correct. Okay, because it's directly proportional. It's tapi the force will be smaller. Okay, see what happens to the direction of the iron ball if the string suddenly breaks. Now this is also a question which actually I asked this before. I'm not sure whether it's me or Cheguhi, but we have asked this question before in one of your exams, either the trial exam or one of the online exams. Okay, and so when we think about it, if you move this thing around, when the string suddenly breaks, what's going to happen is that this ball is going to fly off in one direction. Okay, it's going to fly off in a straight line. Okay, it's no longer going to move in a circular motion. It's going to fly off in a straight line in a certain direction. So of course the problem is, how do we write this answer? Okay, macam mana kita mau tulis jawapan ini sekiranya ini adalah soalan yang keluar. Okay, so let's kind of standardize this so that we can, we can get it all right lah. Okay, so it will move in a straight line in the direction of tangent to the circular path. Okay. It will move in a straight line in the direction of the tangent to the circular path. That is the right way to answer this in a sentence lah. For us, when we see, oh, dia akan terbang secara lurus lah, dia akan terbang lurus lah. Sort of lurus lah, kan dia akan naik dan turun lah. But definitely it will terbang lurus out. Okay, but always the problem is macam mana kita mau tulis ini sebagai jawapan. So I'm offering this suggestion to you lah. Okay, try to memorize this answer. If this question comes out lah. Okay, it moves in a straight line in the direction of tangent to the circular path. Okay, so as you can see, it is a tangent, okay, to the circle over here. Okay, so that's what it means lah. It moves in a straight line in a tangent in the direction of the tangent, in the direction of tangent to the circular path. Okay, so pretty easy question, 4 marks only for question number 1. Okay, this is also a similar question to the one that we discussed in the SBP paper, okay, which is a nuclear reaction question. Okay, which kind of makes me think that, okay, now got 2 papers already asked nuclear reaction as part of the short questions. So it may be a question that will come out this year. Okay, so first of all, state the nuclear reaction that occurs. Okay, just to recap, there are only 2 types of nuclear reaction. It is either nuclear fission or nuclear fusion. The word fusion is more familiar to us. It's about like fusion food lah, kan all these things are makanan yang bergabung. But this is obviously not case di mana dia bergabung. So the answer will be nuclear fission. Okay, that's the first one lah. Now in diagram 2, the neutrons produced continuously bombard other uranium nuclei and release a large amount of energy. So name this reaction process. Okay, this is called a chain reaction. Okay, dia akan sambung-sambung. So, dia akan sambung lah. So chain reaction is a continuous nuclear fission yang berlaku. Kalau setakat nuclear fission one time boom begitu saja kan, tiada. Ini boom 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 boom. So continuous nuclear fission, okay, is known as a chain reaction. Okay, but there is a condition for this chain reaction. Okay, and yes, we did talk about it in our lesson. Don't know when, but maybe you have forgotten, so it's a good thing for us to remember now lah. Okay, the condition is very important, which is the mass of uranium 235 must exceed the critical mass. Okay, when we say critical mass, means you need to have, it is like the threshold frequency punya concept lah. Kan threshold frequency is the frequency must be above a certain level. Kan then only the photoelectric effect will happen. That's in chapter 7. So critical mass is the same thing. You must have enough uranium-235 in order for the chain reaction to continue. Because remember, every time a nuclear fission happens, the uranium akan berkurang. Okay, so the uranium akan berkurang until a certain part where dia sudah kurang daripada the critical mass. Okay, we cannot say threshold mass, so it's not the right term lah. Okay, but actually it's called critical mass. So it's minimum amount of mass needed, okay, for the chain reaction to happen. Okay, kalau mass of the uranium sudah kurang daripada critical mass, that's it lah. The chain reaction will stop. Okay, because there's not enough uranium to go around to continue the process. Okay, so this is one of those answers where itu saja jawapannya dan dia harus ditulis dalam bentuk begini. Okay, nuclear reaction above is represented by the following equation. We can calculate the value of x and y lah. Okay, all we need to do is just balance the left and the right. So here, the top here is 236. This will be x plus 92 plus 3 times 1. Okay, so 236 equals to x plus 92 plus 3 times 1. And you can do the same thing for y, which is at the bottom. Okay, oh no. Sorry, I should rub this off. It's so confusing. Okay, sebelah kiri is 92. Okay, on the left is 92. Plus 0. Oh, yeah, this is 236 because it's 235 plus 1. Okay, so sebelah kiri is 92, sebelah kanan is 56 plus y plus 3 times 0, which is actually 0 lah, so we don't need to bother with that. Okay, so when you calculate this, you will get x equals to 141 and y equals to 36. Quite simple lah. Okay, nothing very special about this question. It's just that so far we have seen 2 questions where the answers are pretty specific. Okay, the tangent one, okay, the move in a straight line in the direction of tangent to circular path, and secondly, the mass of the uranium-235 must not exceed the critical mass. Now, this uranium-235, dia mungkin berubah lah. Okay, in this case, we are using uranium-235, but maybe we can be using another nuclear material. It can be thorium. Okay, so make sure that you get the concept lah. The concept is that the mass of whatever bahan yang kita pakai mesti melebihi, okay, the critical mass. Kalau dia kurang sudah, chain reaction cannot happen. Okay, that's the key to this lah. Okay, number 3. Diagram 3 shows a projectile motion of a stunt action performance. Yeah, sometimes human beings are nothing better to do than to perform stunts. So a human cannonball is fired with a high momentum to the air at an angle of 60 degrees. So this angle here is 60 degrees lah. Okay, over here. Okay, so let's take a look. What is the meaning of momentum? Now, the definition for momentum is one of those definitions where actually it is taken from the formula. Let's check and see whether the formula for momentum is given or not. Let's see, there it is. It is given, but you cannot write the formula as definition. Okay, I'm just saying that the formula helps us to remember the definition, because the definition of momentum, okay, sorry, momentum is m times v, and momentum is m times v. So the meaning of momentum is product, hasil darab, okay, product of mass and velocity. Okay, that's the definition for momentum. So the formula helps us for this. But not every definition yang menggunakan formula, kita boleh ambil formula itu sebagai definition lah. Okay, I'm just saying that power is one. Okay, remember the length one? Power is the reciprocal of the focal length, 1 per f. That's one. Another one is momentum. Okay, there are very few definitions. Sikit lah sebenarnya definition yang kamu boleh ambil dia punya formula dalam bentuk ayat. Okay, so power is one of them, momentum is another one of them. Okay, the mass of the cannon is 250 kg and the mass of the human cannonball is 50 kg. Wow, the guy is very light, 50 kilo saja dia. Now, after explosion, so we know that this is an explosion event. Okay, the cannon recoils at the velocity of 3.5 and a human cannonball moves forward, okay, with a velocity of v1. So let's take a look at this. After explosion, okay, after explosion, this is the cannon. Ding, ding, ding. Sorry. Okay, so the cannon is going to move backwards with 3.5 meters per second. Now it's going to move backwards, which means the velocity direction is very important. It's going to be negative 3.5 meters per second. And the human cannonball, okay, yang terbang ke depan is going to move with a velocity of v1. Okay, but this is after. So what happens before? Okay, before both the cannon, okay, and the guy are stuck together lah. Okay, and they are both not moving, bahkan. If they are both not moving means both of them have no velocity. And if they have no velocity means they have no momentum. So the total momentum before the explosion would be 0. Okay, 0 momentum total. Okay, And then after it'll be, the one in blue lah. So naturally, the next question will be calculate the velocity of the human cannonball. So before explosion is 0. Okay, after explosion is formula for momentum is mv bahkan. So the momentum of the cannonball will be 250 times negative 3.5. 250 times negative 3.5. Why negative? Because the cannon is moving backwards. Okay, plus, total momentum. Apa yang kita sedang kira di sini ni adalah total momentum. So before explosion, 0. After explosion, cannonball punya momentum plus our friend's momentum. Okay, the guy is 50 kg, so it's 50 times V1. Okay, and according to this physics principle in C, which is the principle of conservation of momentum. Okay, namanya sangat panjang lah. It's a very long name, but it needs to be written in full. So based on the physics principle, which states that the total momentum before must be equal to the total momentum after. So because of that, I can say that 0 equals to 250 times negative 3.5 plus 50 V1. Okay, then you do your calculation, and you will get V1 is about 17.5 meters per second. Okay, I will leave you to do this calculation for yourself. But the idea is that you count before, you count after the total, momentum, then you kasih sama dengan, okay, kasih sama dia orang. Then that's the principle of conservation of momentum. Okay. Now, based on diagram 3, state one modification that can be done so that the human being can be fired further. So, our design is not very far, okay, but it's very high. Okay, so how would you modify this setup so that it can go further? We want him to go further. It may not have to go higher, but he definitely needs to go further because itu kehendak soalan lah. Okay, so obviously the first one and the most logical one is to reduce the angle of the cannon. Okay, that's the most logical one. Kita kasih turunkan sikit supaya dia boleh pergi lebih jauh. So kita tidak mau dia pergi lebih tinggi. We just want him to go further. Okay, another possible answer for this would be to reduce the mass of the human. Okay, either by dieting or change person lah, use somebody lighter. But 50 kg is pretty light actually. If you go with somebody lighter, senang dia terbang lah. Ini logic, very logical. Use somebody that's very light. Okay. Another one which I can also accept is to increase the mass of the cannon. Because when you increase the mass of the cannon, the recoil is going to be shorter, smaller, and so dia boleh terbang lebih jauh lah, okay, or lebih tinggi lah, okay, in our case of the 60 degrees. So either one of these 3 answers is acceptable. Okay, and again, I was telling ST this morning, if you think about it, all these are very logical answers. Okay, it's very logical because physics is very logical. Yeah, physics is very logical and no need to think so hard. Okay, well, sort of lah. I guess you have to think hard lah, but sometimes logic can run. Okay, reduce the angle, increase the mass. Okay, all these are answers that can be accepted. Okay, diagram 4.1 shows a transistor circuit which acts as an automatic switch. Now the air conditioner will be switched on automatically when the room temperature is more than 28 degrees Celsius. What? 28 degrees Celsius? Want to turn on the aircon already? So sad, no? It should be hotter. Okay, name the type of transistor used. If you notice, the arrow is going downwards. So the arrow going downwards is an NPN transistor. Okay, the terbalik transistor, if the arrow is going up, okay, the arrow going upwards, it's called a PNP transistor. There are only two types of transistors in your syllabus lah. Okay, so the arrow is the one. Okay, the arrow in the symbol is the one that tells you whether it's an NPN or PNP transistor. Okay, which statement correctly describes the function of the relay switch? Okay, the relay switch is here. Okay, is it to switch on the secondary circuit or to switch on the collector circuit? Secondary circuit refers to this one. This is the secondary circuit, litar kedua. Okay, secondary circuit is this. Or is it used to turn on this one, the collector circuit? Okay. Now, if you remember your transistor stuff, you will know that sometimes instead of relay switch, what we will put here is maybe a speaker or an alarm bell. Okay, and so and so that one is because of the collector circuit. Okay, but this question is not asking for that. This question is asking what is the function of the relay switch. Okay, the relay switch, the function is so that it will complete the secondary circuit. So it has to do with the secondary circuit. Okay, so the one that you should be taking is to switch on the secondary circuit. Okay, relay switch is used to that. C, the transistor is switched on when the base voltage is 4 volts. Okay, now let's consider this. Dia cakap transistor ni akan on if this base voltage is 4 volts. Okay, now we have a total of 6 volts together. And remember that potential difference, dia macam membagi-bagi saja. As long as you're on the same line, you will have the same amount of voltage as the source. Okay, so logically, you can tell me the potential difference across the thermistor. Okay, which is, kalau sini adalah 4 volt, this voltage will be 2 volts. How do I know? Because 2 plus 4 is equals to 6. The potential difference is the same across the same 2 points. Okay, so it will be 2 volts. And so it's only 1 mark ni. Tiada apa-apa yang mau dikira. You just have to know, okay, the concept of potential divider. Okay, potential divider, and this is a formula that is usually not given in the formula list lah. You need to know how to calculate the potential this one. So the minimum resistance of the thermistor. Okay, so let's take a look at this. Let's take a look at this. We know that the resistance of the normal resistor here, okay, is 7K. Okay, 7 kilo ohms lah. Okay, so we want to find this resistor. How much is it? And we know that this is 2 volts and this is 4 volts. Okay, at the bottom over here is 4 volts. So according to the potential divider formula, okay, the resistance of this, okay, can be calculated by using resistor over total resistance. Okay, total resistance is R plus 7,000. I changed the 7K to 7,000 equals to the voltage over the total voltage. Okay, and this is a very specific to transistor punya soalan lah, the potential divider circuit. It's very specific to transistor. Okay, so 2 volts, the resistor of the 2 volts, okay, it's like nisbah lah, like ratio lah. Okay, the resistor of this one, and then over R plus 7,000 equals to 6. So you can write this over here lah. R over R plus 7,000, okay, equals to 2 over 6. And you can find the value of R. Okay, you get R is about 3,500 ohms or 3.5 kilo ohms. Okay, either one of this will be fine. Okay, but we only think about this formula, okay, or this ratio, okay, when we talk about transistor. Okay, and especially the potential divider circuit lah. Okay, so that's a very specific one. Okay, diagram 4.2 shows a graph obtained from an activity to study the relationship between IC and IB. Okay, so IC is over here. Sorry, IC is, yeah, okay, IC is over here lah. Because this is the collector, this is the base, this is the circuit. This is the IB. Okay, the current flowing across here is the IB, the current flowing across here is the IC. So the relationship between IC and IB, okay, is given in this graph. Okay, and we see these two numbers here, 62 and 0.4. So the question will be, based on the graph, calculate the gradient of the graph. Now this one is a very strange question to ask in this one paper too. Okay, but okay lah, calculate lah. Okay, the only thing that I want you to notice is that, okay, and this is where it gets interesting lah. Okay, is that if you use IC and IB, hold on, okay, you don't really have to change the ampere to the milliampere to ampere, because both are using the same unit, okay, which is a little bit, not to say strange lah, okay, but sometimes we can get graph where atas di sini dia pakai microampere, di bawah sini dia pakai milliampere. Now when that happens, you have to change it all to ampere. Okay, so in this case, if let's say you want to just, don't want to change the milliampere, okay, you know that this is 0.4 and 62, makan. So you can calculate the rate gradient lah. 62 minus 0, 0.4, sorry, 62. 62 minus 0, 0.4 minus 0, and you'll get 155. Okay, which is the same answer as if you change it to ampere. Okay, so 62 milliampere will be 62 times 10 to the power negative 3 minus 0 over 0.4 times 10 to the power negative 3 minus 0. You will still get the same answer, 155. Okay, you still get 155 because both are using milliampere. Okay, I just want to caution you that sometimes the graph can be 1 in microampere, which is microampere is times 10 to the power of negative 6. Okay, so if it is in microampere and then the other one is in milliampere, then you definitely have to change. You have to change it to a common unit. So the good thing about this question is dua-dua kita pakai milliampere. So you got nothing to worry about. Pakai je lah 62 bahagi 0.4. No problem. Okay, but this number, okay, this number, the gradient of the graph is something that I only mentioned in passing during our class. Even I also forgot about it for a little while because jarang banyak this soalan. So what is the physical quantity represented by the gradient of the graph, which is IC over IB lah, kan? Y-axis over x-axis. IC over IB. So the physical quantity actually is the amplification. Amplification factor. Okay, beta. I want to stress here that you cannot say just amplification. Okay, because this is a very specific electronics term. Okay, orang dalam dunia elektronik dia beta is known as the amplification factor, bukan amplification sahaja. You know, like in bila kita cakap pasal lens atau dalam matematik pembesaran enlargement, we just say the magnification, apa itu? It's called a magnification factor lah. Also the same amplification factor, faktor pembesaran. Okay, ini adalah faktor, what's amplification? Pembesaran juga lah. Okay, but the word factor cannot be missing. You don't have to put a symbol if you don't remember, but the gradient of the graph IC against IB is known as the amplification factor. Now, besides being an automatic switch, state another function of the transistor. Transistors, two main functions. One is automatic switch. The other function is current amplifier. Okay, again, these are like macam fakta-fakta lah. What is the function of transistor? automatic switch and current amplifier. These are the two main functions that you learn. I'm not saying that those are the only functions, but there are more functions than that. But the two main ones that you study in your Form 5 physics is these two. Okay, it functions as an automatic switch and it also functions as a current amplifier. Okay, all right. Sorry, not to say let's lah. Okay, I'm going to let you take a short break because I want you to do the comparing and the relating question first before I give the answer. For both question number 5, and you can try question number 6 if you want, but question number 6, the comparing question is a little bit strange lah. Okay, so I'm going to give you 5 minutes. Just give it a try, the comparing questions, and then 5 minutes later, we'll come back and we'll continue our discussion. Okay, give it a try first. Okay, let's continue. So, this one, okay, diagram 5.1 shows the reading of the Borden gauge before the piston of the gas container is pushed inwards. Okay, so if you take a look at this, the one thing that remains the same is the temperature. Okay, temperature is constant. Now, constant temperature, which means that is P interacting with V lah. Okay, P and V are the ones that are interacting. Okay, and P and V is usually Boyle's law lah. Okay, so the Borden gauge, okay, measures definitely temperature is out lah. Okay, and volume, you don't use a gauge to measure the volume, you use to measure the gas pressure. Okay, this is kind of like the meter that you see at the petrol station when you fill in the air in the tires, makan. Okay, so you see that. So that's sort of a Borden gauge also lah, but it's used to measure gas pressure, okay, or the tire air pressure. Okay, so let's compare. Compare the volume of gas in the container. Okay, yeah, if you can see the volume of gas, this one got more volume or this one less volume. So 5.1 is more than 5.2. Okay, when you compare the reading, okay, it's very clearly seen lah. Okay, you will see that 5.1 is less than 5.2. Okay, now you compare the number of molecules. How do you compare the number of molecules? When you count log, kan, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's an interesting question because it's like some people will overthink this, you know, like, how do you know the number of molecules? Count how many circles there are. Okay, so the number of molecules are the same. Okay, so state the relationship between the volume and the reading. So in this case, okay, you notice that it is the volume that affects the reading. So the volume must come first. Okay, so the bigger the volume, the smaller the reading. Okay, I'm giving you shortcut versions, short form versions. The bigger the volume, the smaller the reading. Because what is changing is the volume. Then after that, the reading lah, kan. So name the physics law involved. This is Boyle's law. Okay, and just to remind you, please make sure that you spell scientists' names correctly. Okay, now this is probably the difficult part lah, using molecular kinetic theory. Explain your answers in 5C1, 5C2. Why? Okay, why is it that when the volume increases, the reading decreases? Okay, so we start with this lah. Okay, when the volume increases, okay, the number of molecules per unit volume also increases. Okay, this is the one. When I say per unit volume, it is essentially saying what, you know? It is essentially saying the space I have increases. Okay, when I increase the volume, the space for the molecules, okay, will be increased. Oh, sorry, decreases. Oh my goodness. The number of molecules per unit volume decreases. Okay, there is more space, although there is the same number of molecules. Okay, when you increase the volume, you give more space for the molecules to move. So that's why the next point is the rate of collision between the molecules and the walls of the container decreases, sorry. Okay, the rate of collision between the molecules and the walls of the container decreases because you are giving the this one more space to move. So dia akan berlanggar dengan dinding itu kurang. Okay, when you give them less space, there is a higher probability for them to bump here, bump there, bump everywhere. Okay, and so the rate of collision between the molecules and the walls of the container decreases. So the force per unit area on the wall decreases. Okay, that's why the pressure decreases, because pressure is force per unit area. Okay, yes, I know there are 3 points over here. Okay, but I would say that because this is a molecular theory, this is molecular kinetic theory, okay, or kinetic theory of matter. I think it's important that we mention everything, especially point number 1 and point number 3. Okay, if you really don't want to remember everything, then I would say if this is a 2-mark question, definitely point number 1 and point number 3 are what I would look for. But if it is a 4-mark question, okay, like for example, essay. If this is a 4-mark question, I would have to write 1, 2, 3, and then my 4th one will be pressure decreases. Okay, as my 4th point. So volume increases, number of molecules per unit volume decreases, rate of collision decreases, force per unit area decreases, pressure decrease. Okay, all these things are in a 4-mark question. But this is a 2-mark question, so I would say 1 and 3 is the more important points. Okay, you give the molecules more space to move, so the force per unit area will decrease. Sebab itu yang berkaitan dengan pressure. Okay, that is the one that is actually related to pressure. Okay, what happens? What happens to the kinetic energy of the gas molecules after the piston is pushed inward? Okay, same thing. Whenever you see what happens, there are only 3 possible answers: increase, decrease, or unchanged. And this is a trick question because the answer is that it will remain unchanged. Why? Because the kinetic energy, okay, the kinetic energy of gas is dependent on the temperature. And awal-awal sudah kita establish bahawa the temperature doesn't change in this entire case. We have nothing to do with temperature here. We don't increase the temperature. What we're changing is the volume and the pressure. The temperature remains the same. And so because of that, the kinetic energy remains the same. Okay, dia masih lagi bergerak dengan kelajuan yang sama. It doesn't become slower or isn't just because you give them less or more space. Okay, so the kinetic energy ada kaitan dengan temperature. And since the temperature is unchanged, so the kinetic energy of the gas molecules remains unchanged. Whether you push the piston inwards or you pull the piston outwards, the kinetic energy will still be the same because the temperature is the same. Okay. All right, number 6. Now this is a pretty special question. Maybe it's a good thing that we discuss this MRSM paper because this comparison question is a very interesting question. Well, interesting. So anyway, this is the height thing. Okay, the number of coils are the same. Take a look at this. Okay, what you need to notice is that the direction of the magnet poles are different. Okay, and you see that even the persona is different. So what is the meaning of a magnetic field? Okay, a magnetic field is a region, okay, in which an object experiences a magnetic force. Okay, just to remind you that if this question is electric field, it is the exact same definition, except that you don't say magnetic force, you say electric force. Okay, the field. Field is a region lah kan, satu kawasan di mana satu objek mengalami, okay, daya magnet or daya electric. So it's a region in which an object experiences a magnetic force, if it is a magnetic field, or electric force, if it is an electric field. Okay, compare the number of the turns of the solenoid. You'll find that when you compare, you count lah 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's the same number of turns. Okay, the number of turns is the same. Okay, this is where it's different now. Compare the polarity that enters the solenoid. So if you take a look, 6.1, south is entering the solenoid, but 6.2, north is entering the solenoid. So this one you cannot say one is bigger than the other. It's a very special case punya comparison lah. Okay, we will say 6.1 is south, 6.2 is north. Okay, 6.1 is south, 6.2 is north. Very special case. Okay, this is a very special case that we don't see very often lah. So whenever we compare, we always think bigger, smaller, bigger, smaller. But this one is also is a possible comparison. Okay, so we want to, if you're familiar sudah dengan bigger, smaller, and it's time to look at other possibilities, okay, that can be there, so that you don't just get stuck in one mode. Okay, compare the direction of the deflection, same thing. Okay, 6.1 is to the right, 6.2 is to the left. Okay, 6.1 is to the right, 6.2 is to the left. Okay, very interesting comparison. Now, this becomes even more difficult when we want to say relate, because relate is the bigger the something, makan. Okay, so again, special case being a relationship. Relate the polarity of the magnet that enters the solenoid to the direction of deflection of the galvanometer pointer. We find that if south is entering the solenoid, the deflection goes to the right. Okay, that's basically it. Okay, when the polarity of magnet that enters the solenoid is south. Okay, polarity of the magnet that enters the solenoid, direction of deflection of the galvanometer pointer. The direction of deflection of the galvanometer pointer okay, is to the right. Okay, kalau kamu tulis yang terbalik, when the polarity of the magnet that enters the solenoid is north, the direction of deflection of the galvanometer pointer is to the left. Also can lah. Okay, it's only one mark lah. You don't have to write both. Okay, kamu tulis satu saja pun cukup. Okay, but the idea is that this is a interesting kind of relationship lah. Okay, in hubung kait yang lain jenis. Okay, so it's good for us to be exposed to this. Okay, what you don't want to do, of course, is to write, you know, the bigger the polarity, the bigger the direction. Okay. Now, based on 6.1, state the polarity of X. Okay. South is entering. So what does X become? X becomes south. To stop the south from coming in. Okay, so this will become south pole. And this law is Lenz's law. Astaga, sorry. Ayo. Sorry. Lenz's law. Okay, LENZ pun boleh lah. Yang penting the LENZ. Okay, Lenz's law is used to determine the polarity of the solenoid. Okay, just to recap, everybody, the two laws for electromagnetism, especially electromagnetic induction, is Faraday's law, okay, and Lenz's law. Okay, Lenz's law is used to determine the polarity of solenoid. Okay, how do you know which side of the solenoid is north or south? That's Lenz's law. Faraday's law, okay, Faraday's law is how to make the induced current stronger. Okay, that's Faraday's law. How do you make the induced current stronger? So add more solenoid, use a bigger magnet, use a bigger force to push the magnet in, not just tolak gitu saja, push with very hard lah. So more cutting of the magnetic flux produces a bigger induced current. Okay, so that's Faraday's law. But Lenz's law is, how do you know which side is north, which side is south? That's Lenz's law. Okay, again, now this is not the definition, but I'm just helping you to see the difference between the two so that you know. Okay, if the question is asking about how to make the induced current stronger, what are the factors? That's Faraday's law. But if you want to know which side is north, which side is south, that's Lenz's law. Sorry, that's Faraday's law. This one is Lenz's law. Okay, so be very careful between these two. Don't mix them up. Okay, the magnet in diagram 6.1 is then released from a higher position. Now, this one, released to the higher position. Okay, so what happens to the deflection? Again, what happened? So the deflection will increase. Okay, explain your answer. Okay, why does the deflection increase? Because there is more cutting of the magnetic flux. Okay, that will be the answer. There is more cutting of the magnetic flux. So this will be 1 mark and this will be 1 mark. Okay. Of course, you can mention Faraday's law also if you want, because according to Faraday's law, more cutting of magnetic flux will produce a bigger current. Okay, so that is also possible. More cutting of magnetic flux means produce bigger current. Okay, that's the idea behind this. All right, let's quickly finish these last two. Diagram 7 shows an object O is placed in front of a convex lens J. Okay, focal length of the convex lens is 4 cm. So here's 4 cm, here's 8 cm, and so on and so forth. Okay, 4 cm, 8 cm. Okay, so what is the meaning? What is the meaning of focal length? Okay, focal length is the distance between focal point and optical center. Okay, or the center of the lens. So it's the distance between the focal point and the optical center, which is this. Okay, this is the focal length. Okay, on diagram 7, draw a ray diagram of the object to form an image. This one, if you've done enough, then you know this lah. Okay, the two most important lines are, the first one must travel from the top of the object directly to the center. Okay, so it will go like this with the two arrows. The second one will be from the object parallel, and then after that cuts the F. Okay, cuts the focal point. And the place where the two of them meet is where the image is formed. Okay, oh sorry. Okay, you find that the image is definitely bigger lah, kan? So the characteristics of this image will be, it will be a real image. It will be inverted. Inverted because originally it's upwards. After the lens, it becomes downward, so it's inverted. And secondly, it is magnified. Okay, which is probably the next question there. Give one characteristic of the image form. So it's either real or inverted okay, or magnified. What if you give all three? No problem. Okay, they will just mark, but they will still give you 1 mark lah. They won't give you extra marks because the question asks for 1. Okay, jangan juga kau mengada-ngada. You can give all three, totally no problem, but you still get 1 mark. Okay, but if you have forgotten, don't forget lah. Okay, how to draw the ray diagram. Okay, the first line, the green one, from the object, just one straight line towards the center. Second one is a parallel line, okay, parallel to the principal axis, which is, okay, it's parallel here. Okay, and then after that, after passing through the center here, cuts through the F. Okay, cuts through the F. And then after that, the place where the green and the blue meet is where the image is formed. Okay, right, table 7, sorry. Convex lens J acts as an eyepiece lens, okay, and needs to be combined with another convex lens that acts as an objective lens, okay, to build an astronomical telescope. So this is something that should be very fresh. We just discussed the astronomical telescope punya objective lens. Okay, you can refer to your notes and see how far you remember about them lah. Okay, but let's take a look at the convex lens P, Q, R, and S. Okay, so when we look at it, it seems that the first, how many things are 2? So the first one is the focal length. Do we want a bigger focal length or do we want a smaller focal length? Of course, we want a bigger focal length lah. Okay, because a bigger focal length for the eyepiece lens, for the objective lens, J is eyepiece already. Okay, but we want to combine the J lens with another lens for an objective lens. So objective lens, kita mau tengok dari jauh bahkan, so the focal length must be bigger. And the reason is, sorry, higher focal length. The reason is to produce a real, inverted, and diminished, okay, image. This is the very standard answer lah. Okay, to produce a real, inverted, and diminished image. Okay, and then of course the second one is the diameter of the lens. Do you want it to be a bigger diameter or smaller diameter? Obviously, we want a bigger diameter lah. Okay, so we want a bigger diameter. Why do we want a bigger diameter? When your lens is very big, you will get a brighter image. Okay, if you answer lens questions enough kan, ni bosan sudah. This is the answer. Ini saja dia punya jawapan tu. Okay, now based on your answer, choose the best. Let's see, only one has been circled twice, which is convex lens S. Okay, so S is the answer lah. Okay, so quite interesting lah, this paper. The astronomical telescope came out in the structure. Okay, berapa tahun sudah I predict that always the telescope will come out in the section B or section C kan. Jarang, satu kali saja pernah. Okay, last question for the day. Diagram A shows a trainee using an elastic pull sit-up spring in her training. Wow. Okay, so a spring is attached between the handle and the footrest of the elastic sit-up spring. When force is applied, the spring stretches and returns to its original position once the force is removed. Okay, so you tarik, the spring will become longer, and then bila kau lepaskan, it will go back to its original position lah. So the force applied can be determined by using the formula F equals to Kx. So formula is given. K is the spring constant and X is the extension of the spring. Name the physics law related with the above formula. Asal spring, asal extension, asal elastic. Okay, it's definitely Hooke's law. Okay, notice that Hooke comes with an E. Also another very commonly misspelled name. Orang ingat Hooke kan H-O-O-K saja. But it is actually H-O-O-K-E. Now the maximum force applied can be applied to the spring, to the elastic sit-up spring is 450 newtons. Means maximum kamu boleh tekankan, kamu boleh tarik is 450 newtons. But what happens if the spring if the spring is applied a force of 500 newtons, yang melebihi 450 newtons. Okay, this is a very logical question lah. Okay, what will happen? Obviously, the spring cannot return to its original length. Dia tidak boleh kembali kepada keadaan asal. Okay, or in other words, okay, it loses its elasticity. Also another possible answer lah. Okay, sebab you overstretch the spring. Kan dia sudah cakap, okay, had saya adalah 450 saja, tapi kau kasih 500 juga. Siapa lah yang boleh tahan kan? Wow. Okay, so the hard is this one. You apply 500, of course it cannot. You will give up and say, oh, apa-apalah. Okay, so dia masih boleh berfungsi, but it won't be, you know, as elastic as it was lah originally. Okay, the second mark is why? Okay, because the elastic limit. Okay, so this 450 Newton is known as the elastic limit. Okay, has been exceeded. Okay, so the purpose of this question is to draw your attention to the words elastic limit. Okay, the elastic limit has been exceeded. That's why it cannot go back to its original length. Okay, or it loses its elasticity. Okay, the reason why this happens. Okay, suggest a modification. So, you know, maximum you can put 450. Tapi saya mau juga 500. Mungkin sebab saya sangat berat lah. Okay, so we need to modify this, you know, this gadget over here lah. Okay, and they give you the ciri-ciri. One, how would you change the thickness of the wire? Okay, secondly, how will you change the number of the springs? And thirdly, how will you change the arrangement of the springs? Okay, let's talk about the modification first before I go to the reason. Okay, so for the thickness of the wire, the spring, ini sangat logic ini. Would you make it thicker or thinner? Of course, you will increase the thickness lah. Okay, increase the thickness. Okay, pakai spring yang lebih tebal. Because the spring yang lebih tebal itu kan lebih elastic, blah, 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 blah. Okay, reason kejap let me go to the modification first. Number of springs. One spring or more springs. Okay, of course you increase. Okay, or higher lah. Okay, higher number of springs. Okay, actually yang first pun boleh ya. Okay, higher thickness lah. A bit weird lah, but can lah. Higher thickness pun boleh. Okay, yang penting dia punya thickness adalah lebih besar. Okay, and lastly the arrangement of springs. Now, spring arrangement only got two, which is either series. Okay, dia bersambung macam ni atau parallel. Okay, like this. So the arrangement of the springs, again, everybody, we want to withstand a bigger force. Okay, so withstand a bigger force, we will definitely need parallel arrangement of springs. Okay, parallel, because kalau dia adalah series, okay, if this is a series arrangement, dia akan menjadi sangat panjang. Okay, but it will not be able to withstand a bigger force. It becomes so long until they putus. Okay, but parallel, it is definitely a much stronger one. Now, the reason why I stopped, why I didn't give the reason is actually for all three characteristics, you can actually give the same reason, which is greater spring constant, or to increase the spring constant. Okay, I'm going to call this GSC lah. So number of springs also GSC, the arrangement also is GSC. You can do that because all this answers the same thing. You increase the spring constant, which makes the spring stiffer. Okay, another one, okay, the greater spring constant can be used for all three, but I'm going to give you alternative answers in case you want to pelbagaikan lah. Now, the thickness of the wire of the spring, besides helping this one, okay, it also, okay, makes the spring stiffer. Okay, lebih, I think the word is lebih keras lah. Okay, it makes the spring stiffer. So this is specific to thickness of the wire of the spring. Okay, the number of springs, more number of springs. Okay, another possible this one will be you will get a smaller extension. Okay, the extension will be much smaller. Okay, and lastly, arrangement of strings parallel, okay, will actually give it a higher elastic limit. Okay, so you can use greater spring constant for all three if you want, or you can mix and match lah. Okay, as how much you can remember. First, how much you can remember for the exam is also one thing lah. But the thing about stiffer, smaller extension, higher elastic limit, it is actually kind of related to that ciri-ciri lah. Thickness usually is associated with stiffer. Okay, number of springs more is smaller extension. Arrangement of springs in parallel is usually associated with higher elastic limit. Okay, so you want to make sure that you get the correct reason for the correct characteristic lah. Okay, jangan campur aduk. Okay. All right. So that's it for today. We will stop here and we will do the section B and section C tomorrow night.